Okay, hello, I'm Tim. I'm back. I did not fix the program yet. I figured that it would be better if I just fix it on the recording with you guys. Of course, it's not live, so it's still just myself. But yeah, let's do this. So yesterday when I was going through my program, I discovered a problem that a mistake I have made regarding the direction of the marking and the direction that's in rows. Well, when I say row, it's not actually rolling. It's actually changing location in y-axis. But on the screen, the ideal circumstances is it looks like if it is rolling. So it looks good, Alright, let's get this thing going. Okay. So let's go through here, right? So there are a number of degrees to the 10 degree mark. Above here represents, because remember the numeric constant above is actually different from the pixel location above. So like the attitude above, it's different from it's different from location on screen above, because like if you go like this is the middle, this is 10, 20, 30, and then it goes -10, -20, -30, So it's like it's in the opposite direction. Yeah. So if you go above in pixel manner, so like that way. You are actually going down in a actual attitude manner, and then I was not being very considerate when I was programming it, so it will be a bug when we're actually running it, and here we're going to fix it. Now I didn't run it yet. You see, debugging process is normally after you test a program. So like after you test a program and then it doesn't work and then you start to see what goes wrong, that's called the debugging. But right now we can still change what we know is going to go wrong, and then it just doesn't go wrong at all. And then although it's not really debugging, it's still a part of the improving process, and it's good. It's a good thing, right? So let's do this. Yeah. So this degree to mark above, we set it according to here. So if it is at the current reading is directly at a is divisible by 10, we know that it is exactly at a mark. So we can do this, and then if it isn't, we can see that degrees to mark below is current pitch, and then find remaining when divided by 10. Now this thing is find remaining, right? And then that kind of means that we are going to attitude below and attitude above. So I'm sorry about my IME. Wait, no. Yeah, I'm sorry about my input method. I'm Chinese, and so like when I'm buying stuff and all that kind of stuff, I like to search in Chinese, because like it's a lot cheaper to do things on Taobao and stuff. I mean, by the way, if you guys want, I can yeah, I mean, I actually recommend going on Taobao. It's like a huge website that all Chinese buy all sort of stuff on there, like. For printed circuit boards and stuff, like that's really cheap. It's not an ad, right? It's just where I buy things. I mean, like you can get like a printed circuit board for like a 10 New Zealand dollar or a 8 United States dollars, something like that. Excluding shipping, of course, and a 10 by 10. No impedance going to track 2-layer. I mean, you can probably still get the price by some websites online. But I mean, on Taobao, there's heaps of companies that actually will just do that price for you, and some of them will even be able to beat it. But there's one that I trust most. I do $10. So and 10 New Zealand dollars. That's around $8 in the United States. Yeah. I mean, that I find that price acceptable to me and my parents, who is actually currently paying for this project up to now. Because I'm still working on my Kickstarter page. Yeah. So from that yeah. So that's about my input method. So this one. So from that we know that degrees to mark below is we are actually talking about a attitude degree. So add yeah, just a it's just like examples here. So like if the reading is 15, this degree to mark above. Oh, attitude degree. I'm sorry, my bad. Yeah, it's here. This degree to mark below is 10 when the actual reading is 15, and the degree to mark above is 20 when we it's like here when we have a reading of 15. Now it's just an example just to make sure that I don't get confused later on and you guys don't get confused when I'm reading my program, right? And mark B, this one is pixel, right? So we see that there's something here that doesn't really match up. So mark below equals current pitch and mark above. Okay, so this part does match up. Yep, this part does match up. The degree to mark below is this one to 10, and the degree to mark above equals 10 minus mark below. So this one is correct. Mark below equals. Oh yeah, no, this isn't pixels. This is a marked value. So I'm sorry, it's going back to reviewing my program, so I might be a little bit clumsy. Yeah, and plus it's the first week I'm back at school. You know, like you guys understand, right? When there was a holiday and then you get back to school and you guys like. Right, so this is a mark value, so it's like 10, 20, 30, you know, like this. About the comment, you can literally just write whatever you feel like in the comment section. Like they just get ignored by your compiler, so it's perfectly fine. Yeah, but sometimes it's a good idea to keep it professional. But like, I think comments like this is fine. Yeah. So mark below is current. So yeah, and for this one, we know the degree to mark below is we know the degrees to mark below is literally 0. So we can go to we can just calculate mark below and mark above directly. For this one, we go mark below current pitch divided by 10 times 10. So you know, like so for example, if you have a reading of 15, divided by 10, it goes to 1. Remember, C++ have a very interesting rounding technique. No. Okay, you see that I made another problem here. So current pitch is stored as float. Now in C++, if you go int divided by something, you get round to int. If you go float divided by something, the actual result is still float. And then that times 10 is still, for example, if it's 15 in, then it gets 15 out. And then it will kind of just ruin the rest of my program. So we need to change that. So in order to prevent that from happening, I think there's a function that we can go use called int. We are having a function. I'm not sure does it do what you want it to do or not. Just search it up, and normally that's normally how it works, and it's normally fine, right? Yeah, you see, then I get a result saying that int is not actually a function. So you see, maybe we can get like something like this. So double round, float round, and then round to nearest. Right, we're using C11, right? We're not using C99. It's a different thing. Yeah, value to round. Yeah, okay, you see that we always want the value, we always want the thing to be the value below it. So floor might be a better function. Search of floor. And that apparently goes to commercials. Better? Yeah. So you have double floor. Yeah, hold up 1 second. Yeah, round x downwards returns the largest integral value that is not greater than x. Right? So we know that clearly works for positive numbers, so we just gotta make sure it works for negative as well. So let's go through this. For example, if the reading is negative 175 divided by 10, that's 17.5, round to 18, so negative 180, and then that will be processed by the program to be positive 180. So that works, right? Yeah. So if it is 165, it will be 16.5, 17, and then the bottom one will be 170. So and then 170 will be we know it's reverse, so 170 will be the one on top of the pointer. And then so that everything checks out. Yeah, so that's good. So I apologize, I got a bit of a personal business to deal with, so excuse me.